Assalamualaikum and hi. My name is Muhammad Dinish Faris bin Muhammad Hamidi. My other group member is Muhammad Mizanur Rahman, Muhammad Harid Shukri and Muhammad Imad Izzuddin. So for this video, we're going to discuss about vectors. So for problem 1, imagine an engineering team need to lift a heavy electrical generator weighing 500 kg using two cables attached to two different anchor points on a ceiling. So the cable A is pulled at 30 degree towards the left, while cable B is pulled at 45 degree towards the right. Calculate the tension force in each cable to ensure that they do not snap under the load in a state of static equilibrium in 2D. Okay. So for the solution, since it is in 2D, axis involved will be x and y direction. Vector components will be T equal to Txi plus Tyj. T means the tension force. Okay, so for tension A, so we will calculate the cos and sine will be negative 0.866 TAI plus 0.5 TAJ. For tension B vector, and it will be negative 0.707 TBI plus 0.707 TBJ. So for the force of weight, we'll be using the formula of W equal to mg, which is mass and gravity. So it is equal to 500 times 9.81 equal to 4,905 Newton. Convert it into vector form. It will be 0I minus 4,905 J because it is in y direction only. Okay, next, in state of equilibrium state, summation of force will be 0. So we have the formula here. Then we just sub the formula into the summation. Then by using simultaneous equation, solution in I and j component, we will get these two equations. After that, we can determine the tension A and tension B, which is tension A equal to 3,590.78 Newton and tension B is 4,398.32 Newton.
Hello, welcome to my engineering mathematical video presentation. This is Mizanur Rahman. Today I want to talk about how the vector are used to model marine navigation. Now, marine navigation involves determining the direction and speed of ship while considering external factors such as ocean current. Problem description. Assume a ship is moving eastward in the sea with a constant velocity. Now next. Mathematical model. Using 2D Cartesian coordinate system is taken as the x-axis and not y-axis. Ship velocity v1 equal to 20 meter per second east and north. Ocean current velocity v equal to 5 meter per second. The resultant velocity is given by v equal to 20I plus 5j. Now solution. Magnitude of resultant velocity v equal to root over 20 square plus 5 square. We get by calculation 20.62 meter per second. And direction of motion tan theta 5 by 20 equal to 14 north of the east. That's all for me. Thank you. Thank you for your attention.
Hello and thank you from panel 2. Now I will continue to explain for my problem which related to a drone and which program to deliver a medical package in a city with many high buildings. Firstly, the question states that we need to find the displacement magnitude of AB representing the drone from the top of the building to the drop off point, which we can find the AB vector from the vector of OB minus the vector of OA. And then we put all of the point for x-axis, y-axis, and x-axis to get the to get the vector of AB. Then we find the magnitude of AB, which we square root all of the axis from vector AB. Secondly, the question wants us to find the scalar product for the drone and the angle for it. Firstly, we find the dot product for OA vector times OB vector, and we will get 24,300. And then in order to get the angle of the drone, we use back the dot product, and we will divide by the magnitude of OA vector and OB vector. And then we will get data equal to 42.42 degree. That's all from me. Thank you.
Okay, so let's jump to the next question. The boom is used to support the 375 Newton flower pot. Determine the tension force developed in wires AB and AC. For this, we solve it using the vector method of static. First, each force expressed in vector form using unit vector. For cable A, B, and C, we determine their direction vectors by using the position vectors R and then convert them into unit vectors by divided with their magnitudes. This allows us to express the force in terms of I, J, and K components, which represent the X, Y, and Z direction. By doing this, each force can be written in Cartesian form, making it easier to apply equilibrium equation later. Next, we apply the moment equilibrium equation about point O, where the sum of moment must be zero. So we got sum of moment at point origin is equals to zero. Then we do the cross product between between the R and the forces that we have, and we equal it with zero. After expanding the cross product, we equate the I, J, and K components to zero. This produces scalar equation that allow us to solve for the unknown forces in cables A, B, and AC, ensuring the system is in static equilibrium. Since the system is in static equilibrium, the sum of moment about each axis must be zero. So, first, we taking the moment about the x-axis, we obtain an equation involving both cable forces, FAB and FAC, as well as the applied load. Then, here we go, the sum of moment at x is equals to 0, 18 over 7 FAB plus 18 over 7 FAC minus the weight, which is 2250, equals to 0. Then the moment about the y-axis is 0 because the forces do not produce any rotational effect about that axis. Then, taking moment about the z-axis, we obtain another equation that relates FAB and FAC, which is the sum of moment in z is equals to 0, negative 12 over 7 FAB plus 12 over 7 FAC is equals to 0. By solving the moment equation simultaneously, we find that the tension in both cable are equal, with FAB equals to FAC equals to 437.5 Newton. So the problem is solved. That's all.